Okay, we are solving a AIPMT question in electric charge moving charges. The question says two identical long conductors AOB and COD are placed at right angles to each other. Let me try to draw a diagram for that. So, this is our AOB. Now, there is COD, there is another one. I have to draw another line. This is our COD, they are right angles to each other. So, I can treat this as COD such that one is above the other, one O is their common point. So, this is our common point. The wires carry a current I1 and I2s. So, let us assume I1 is carrying a current I1, AOB is carrying a current I1 and COD is carrying a current I2. A point P is lying at a distance D along a direction perpendicular to the plane containing to the wires. So, where is the point P? I cannot show. It is if this is in x axis, if this is in y axis, your point is on z axis perpendicular to both of them, out of the paper, out of the screen at a distance D. This is the point P. What is the magnetic field at this point is the question that is being asked. Now, look at this. Here a current I1 is passing and perpendicular to that conductor at a point D there is a magnetic field. How much is the magnetic field due to I1? I can write B1 as mu naught by 2 pi I1 by R, that is D. I need to know what is the direction of that is, right. To know the direction of that, we can first we need to know where is your point P. See, let me just shift this diagram, just give me a moment. I will simply shift this diagram here to tell you about the direction. See here, this is how it is, right. Sorry, this is how the direction is, right. So, whenever there is a current carrying conductor, to find the direction of the magnetic field, what shall we do is, we shall hold with our right hand in such a way that the thumb indicates the direction of current. Then look at this curled fingers. This curled fingers gives the direction of the magnetic field. So, if you imagine a point P outside the paper, that is somewhere here. So, on that if you see how the fingers are curled at that paper, they are like this, they are downward actually, right. So, on this paper, on this point, B1 is in this way, in the z axis downward. Look at the second one is also carrying a current. He has not mentioned direction, just to coincide with my diagram I will assume that I2 is outward, does not make a difference because you only want a magnitude. Now, again I have to find out the direction of the magnetic field due to this I2 in perpendicular to the plane of this, that is perpendicular to the screen at a point P. So, let me move the other diagram now, this image now. So, B2 is also the same value as that of B1, but we can say B2 is, as the current is different, mu naught by 2 pi I2 by D. I want to emphasize on the direction of that. Where is that B2 is? Look at this. You hold the pen or paper something and hold your curled finger. See how is your curled fingers are. That is the direction of the B2 where your curled fingers are there. So, on the z axis I could be showing like this, right. You visualize with the help of a pencil and curled fingers, you can identify it better. So, one thing is very clear that this B1 and B2 are perpendicular to each other, right. Once if you identify that these two are perpendicular to each other, we can write resultant at the point is root of B1 square plus B2 square, because these are perpendicular to each other. So, the value is mu naught by 2 pi 1 by D root of I1 square plus I2 square. Option D is the answer for the problem. That is how we solve the problem. We need to visualize the directions, therefore be careful in doing so, right. Thank you for watching.